Hello and welcome. In this video, we're going to talk about some of the most important Python methods and attributes that anybody who practices data science definitely needs to know. So what are we going to cover here? We're going to talk about a list of methods and attributes that are most commonly needed in our day-to-day work. In fact, if you've been observing codes, you might have already seen some of these being used, but these just appear for an instance and we may not necessarily recollect. So the purpose of creating this video is to provide you a good collection of these methods and attributes at one place so that whenever you need them, you can refer to this and get going. What are we going to talk about? So we're going to talk about a list of about 12 methods and attributes. By the way, we may use the term functions and methods interchangeably. If you studied object-oriented programming, you would know there's a difference between the two. But for our purpose right now, it wouldn't make much of a difference. So we will use functions and methods interchangeably, and attributes are somewhat different. We'll talk about it as we go there. We're going to cover each of these one by one with proper examples, because some of these are applicable to pandas data frames and some of these are applicable to NumPy arrays. We're going to call it out properly when we do the hands-on piece. Let's get started. So we are at the Google Collaboratory and we begin by importing the basic libraries, NumPy, pandas, and Seaborn. Seaborn not for visualization this time, but to call the dataset that we'll take as an example and work on it. So once we are done with this, we are loading this dataset from Seaborn library. This dataset is a very popular dataset called tips, a basic dataset, but it'll be good enough to help us understand all the methods and attributes that we want to apply. So let's just load it. I'm loading it by the name of an object, which is tips. And then we are just checking the first few observations of this dataset. I'll give you the context as the data appears here. So this dataset is essentially about people who have visited a restaurant, and we have features like what was the total bill amount, how much is the tip they paid, what was the gender of the person who paid the bill. It could be a group of people, but who paid the bill? It was a female or a male. Then was the person a smoker or not? What day of the week it was? What time of the day it was? Was it dinner or lunch? And lastly, the size, which captures how many people were there. It could be anything like 1, 2, 3, 4 or more people, depending on how many guests were there. Now let's first begin by using the method apply, and we've sorted them in alphabetical order. There's no specific order that we're giving to a method in terms of its importance. So apply is a method which essentially is used when you want to apply a user-defined function to your entire data. For example, let's say we have a total bill amount, but we want to apply a certain tax amount to all those bills which are above $20. So we have the bill amounts here, but wherever the bill amount is more than $20, we are saying we want to apply a tax amount. How do we do that? We'll first have to write a function. Now, this is how the typical functions are. We are putting a user-defined function with the keyword define, and that's called add tax. That's a name given to the function, which takes the input as the total bill and then checks if the total bill is greater than 20. It multiplies the total bill amount with a 1.18, which is kind of adding an 18% tax. Otherwise, which means if it is not greater than 20, we are simply passing the bill as it is. So this user-defined function add tax is what we want to apply to our column total bill so that we can get a new feature, which is bill with tax. This is the whole objective. And how do we apply this? We are using a method. Why we call it a method? Because methods are the functions which are attached to the object. We can directly apply it to a pandas series or a data frame like this. What are we saying? We want to put this function to use through apply. And what would this lead to? This would lead to a new feature in our data set, which will be called bill with tax. Let me just run this and show you the outcome. So you can see there's a new column that has come, which is bill with tax. This bill, as you can imagine, was more than $20. We've added an 18% tax, and this is the bill with tax here. Now let's move to the second method, which is called cut. This essentially is used to discretize numerical column. So we know there are different types of data. There is continuous numerical data and there is discrete data as well. Continuous data essentially is a collection of numbers which are continuous in nature. You can divide them in infinite intervals. And a discrete data is something which is broadly classified into categories. So what we're doing here is taking a column like total bill, which is a numerical continuous feature, we are binning it. What kind of bins we want to create? We've given the bin boundaries and we've also given the bin labels. So for these values between 0 to 20, it's going to create a label which is less than 20. For values between 20 to 40, it's going to create something like this. And there are a couple of other options for customization, like include right is equal to true or false. You can read about those in the function documentation. But let's see what happens here. This will lead us to a column which will be a bill category column that we are appending to our data frame. If you see the head of the data frame, you can see there's a new column called bill category, which has been added now. So cut is used to discretize a numerical variable which is continuous in nature, and essentially by performing the binning. Next, let's move to the method called enumerate, which is used for adding index and value. Now, how is that useful? Let's understand this. Let's say we want to find out the first 5 customers who visited with more than 4 guests. So let's say there's a special prize on an occasion where you say any customer, any guest who visits with more people would be given a surprise gift. Now, how do you find out? And you're saying that this is a limited time prize. It'll be given to the first 5 customers of this nature. First 5 customers who visit with 4 or more people, right? So how do we do this? Whenever the size or the number of guests visiting is more than 4, we qualify them. It's just that we want to take those first 5 observations, right? So we are going to use enumerate. Now, what are we saying here? For index, comma, row, in enumerate, we are saying tips.iter rows. Now, if you see, iter rows in itself is a method which iterates over all the rows of the tips data frame. Now, what we are referring to is whenever the size is greater than the threshold, we are printing a statement, customer at index. We're taking the index value or the row ID, visited with more than the number of guests here in these curly braces. We'll pick the exact number of guests that visited. It was 4 or more, so it could be anything greater than 4 guests. So this kind of sentence will be printed. And then we are saying we want to keep a counter for this. We initiated the counter at 0. If we find out anybody who's appeared with the number of guests more than the threshold, we are going to increment the counter. If the counter reaches 5, we are going to break this execution. Remember, the task was to capture those first 5 customers who visit with 4 or more guests. That's the objective. So we are applying it in a sequential way. So the purpose of using this row 1 size here essentially is to extract the value of size from each row as we iterate over the data frame. And finally, we get the indices of those observations where the customer appeared with more than 4 guests. Let's just run this. It's going to properly give a statement out which says the customer at index 125. Imagine you have skipped the first 125 records to directly reach to this index. Indexing starts from 0 in Python, right? So 0 to 124, you could just skip those smartly and straight away point to the index where somebody appeared with more than 4 guests. And likewise, more combinations like this. So we are able to enumerate over an iterable. That's the whole idea. There can be multiple ways to do this in a data frame, but this is one of the ways you will often see is being used. Essentially, the enumerate method adds an index to an iterable. That's the bottom line. If you have a list and you enumerate over a list and you try to print the values of the list, it'll also, along with the elements of the list, print the indices. Next in our list, we have iloc, which is an attribute. It is not a method. It's not doing any calculation. It's just fetching some information about the data. And this is applicable to a pandas data frame. Let's say you want to extract a specific element. If, let's say, in the tips data frame, you want the element which has a row index of 0 and column index, it'll just fetch that one value for you. If you want to fetch some observations, let's say you want not all the columns, but specific columns like with index 0, index 1, and index 3, and all the rows, including the 6th row. So this is integer-based indexing. You're giving the exact integer-based index to fetch the information from the data frame. Let me run this for you, and you'll get to know what it fetches, right? So if you see, it has fetched us a value, which is a single value of 16.99. Why? Because we said index 0, 0. What does it mean? Index 0 for a row means the first row, and index 0 for a column means the first column. That's why it's fetching us the value 16.99. Then in the second part, we said we want to extract certain number of rows and certain specific columns. So of the total number of columns, it has only picked up those columns for which we provided the indices. Notice that iloc excludes the value of the index that we've mentioned here. So it has fetched all the values from index 0 to index 5. Essentially, it has fetched 6 values. This index 6 itself is not included. Likewise, if you want to be selective about the number of rows, so for example, here we said everything from the beginning to the index 5 is what we wanted to fetch. But if you want to be selective there as well, you want to specifically fetch a few rows with some specific index values, you can mention those here properly. So 0 to 5, 8 are the only rows that we are fetching now, and we can print it like this. So you're just giving that input like a list. Notice that iloc uses square brackets. Typically, for methods, you would see parenthesis being used, but this is an attribute, and it fetches the specific index values 0, 2, 5, and 8. Very similar to iloc is the lock, which is nothing but the label-based indexing, and we can just apply it to the data frame directly. The difference is here we can use the labels. Our rows were all indexed from 0, 1, 2, and so on. So we will not be using a different label for that. Had it been a different name, we would have used that name here. But for columns, because we're using lock, we can mention the exact column name. We don't have to refer to the index of the column. So depending on the case, for rows and columns, we can use the exact names as they're being referred to in the data frame. Let's say we filter out a specific observation, which corresponds to the first row and the feature called total bill. So you can imagine this will be the same value, 16.99 it's going to fetch. :5 we are writing here, and we want some specific features, we can mention it that way. Let me just run it and show you the outcome. So now there is a subtle difference here. If you see, when we looked at iloc and we did something similar, we did up to 6. Sixth index was not included. It considered indices up to n-1, 0, 1, 2, 3, 4, 5. But the record at index 6 was not displayed. When you execute the same kind of task using the method lock, it includes the value that you passed here. It's actually, when we use 5 here, it is actually displaying the value at index 5 or the row at index 5. A major difference between lock and iloc. This is just the way it functions. And then here, if you see, we have mentioned these specific feature names, and only those features have been selected. Similarly, if you want to select specific rows, you can give the labels of the rows, which will be 0, 2, 5, 8. Let's say we've selected, and the specific column names, it will display the columns exactly the way we want. Now moving on to another popular method called map. And there are some similarities between map and apply as well. I would encourage you to read that on your own. But one difference where you can use map very smartly is that you can also use it for a common task called encoding. For example, we have a feature called time, which captures 2 values, dinner and lunch. Let's say for our model, we want to encode this as 0 and 1. We can always do that using the map method. So we're taking the time column. We are saying dinner to be represented as 0 and lunch to be represented as 1. Why is this needed? Encoding is a very important part of data preparation, and there are other ways to do it as well, but map also comes handy to do this. Let's just run this, and you can see that the variable called time has now been converted to an encoded representation, 0 and 1. Now let's move on to another important method called pivot tables. Again, this is applicable to data frames. Let's say to the same data frame, we want to apply pivot table, and we want to see an aggregated output. Some of you might be already familiar with pivot tables if you've been using Microsoft Excel. It's a very powerful functionality in Excel, which is very popular. But in Python also, for pandas data frames, again, we can use pivot table. We have to give some inputs. So let's go through these one by one. What are the values that you would want to display in your pivot table? We would want to get the values around the total bill. What will be the index of the pivot table? We are saying time, which will be dinner and lunch. That's how the feature is in our data set. Columns will be day. And do you want to aggregate these values to something? We are saying we want to aggregate these to, let's say, average. We can sum them. We can take an average. We can perform various operations. And if we do not have a specific value at a given place, let's say the value is not present. For example, you could have a combination of a particular day when nobody came for lunch, hypothetically. Then we are saying just fill the value 0 there. Otherwise, it will not look nice. Let's see what is the output that we get when we apply this. So now you see something. It is giving us index time, which is lunch or dinner. And the columns are these days. So we seem to have 4 days in our data sets: Thursday, Friday, Saturday, and Sunday. And these are the average total bill amounts. And like we use the fill value here, looks like we didn't have any data for lunch on Saturdays and Sundays. And that's why it is displaying a 0 there. So now looking at this, you can identify which day of the week and what time of the day you get the maximum total bill amount. So looks like it's a Sunday and then Saturday. It looks like weekends, the total bill amount is relatively higher compared to the rest of the days. Not talking strictly in a statistical sense, but just looking at the values and comparing. I hope you get the idea. What if the data given to you is summarized like this to begin with, but you want to see it in a normal long format? And I'll give you more examples on that, but let's understand if we have to do it, how do we do it? For that, we have a function called melt. Now, this would do the reverse of pivots. Pivot table, if you see, has been used to generate a specific output of a certain shape, which is an aggregated output. But melt is going to roll it back to a long format. So we are taking the same object here, which is day-wise average bill, as the input to melt, and we are doing a reset index. Now, what does this reset index do? In a pandas data frame, every observation is indexed. Every row is indexed. Reset index takes it to a default integer indexing, which is 0, 1, 2, 3, 4. ID variables, typically whatever was the index in your original pivot, you'll put it as the ID variable. Variable name is the entry at the column that we had, and value name is the average bill, because we want to segregate these values. Just in a second, you'll see how the output changes when we apply melt. Literally, it shows you a melted or a long form output. Let's see how it works. So you see how this information is? It's actually the same information that you see here. It's presented in a long form. Now, why do we need this? There are specific functions at times which require input in a certain format. If you do not give the input in the right format, it may not work. You may have studied it in some other language by the name of stacking or unstacking as well. But if you see, it's kind of giving us at the lunchtime on a Thursday, what was the average bill? At the dinner time on a Thursday, what was the average bill? And things like that. Same information, but in a melted form. Let me give you another example to make it more meaningful for you. So let's say we just generate some random scores for two employees between 0 to 100. When we do a random number generation like this using NumPy, the upper value is not counted, right? So it will generate values from 0 to 100, both inclusive, and we're generating 10 such values. Similarly, for employee B, there's a score. So there's a category called employee, which has two options, A and B, and they have some scores. This would be some data frame which will have two columns, and each column would have the scores corresponding to each employee. This is our original data frame. This is how we've created. Now, if we apply melt on this, it is going to create one feature which will be employee and a value which will be corresponding to these scores. So let's just run this and see the output, and then you can maybe appreciate the difference. So let's say you get the data like this. Each column represents a different employee and the employee's score. But when we talk about machine learning and data science, a lot of our algorithms would understand data in a specific way. So for example, they'll say, if it is employee, that should be shown in one column. If it is score, there should be a separate column for it. On the other hand, when is this format appreciated? This format may be needed for performing hypothesis tests. You may want to be comparing employee A and employee B. So I'll show you how to get to this state. But let's say you start with this state. How do you get to a long form data? So it has created a feature called employee, which has two options, employee A and employee B, and these are the corresponding scores. For a specific variable, most of the machine learning algorithms would appreciate a consistent input in the long form instead of this kind of an input. If the nature of the information you're capturing here is somewhat redundant, then you may want to convert it to a long form. Now let's look at this problem in the opposite way. Let's say to begin with, you had a data in the long form. So we are generating some values. We've given a list of values here. We could have also generated using NumPy random, but we've just listed it down here. So we are looking at 10 occurrences of employee A, 10 occurrences of employee B, let's say it's some column, and corresponding values. Essentially, it would look like this, the melted form. And then we are rolling it back to this kind of form. And how do we do that? We'll be using something that's known as pivot. Now, in order to do this, the first thing that we have to do is that for the melted data, we need to reset the index. We don't have to consider the index. In fact, we'll drop it because all this work would happen only on the index values. Then what we are doing is group by. So we are grouping by the employee. There's a feature called employee. We are applying the group by method on it. And then we are using something called as a cumulative count. So what is this count? It's going to consider the indexing by each category. For example, if you have 10 values for employee A, it'll consider them as 0, 1, 2, 3, up to 9. Similarly, for employee B, it's going to consider the categories index from 0 to 9. This is the purpose of this cumulative count or cum count. Now, we are using a method called pivot. We've already seen a pivot table earlier, but this is pivot. Simple pivot, because we are not aggregating values here. Pivot tables aggregate values. Pivot would not. We are mentioning a group index, which is nothing but the unique index as we'll find, and then the column title, which will be employee, and values, which will be nothing but these scores. So when we apply this pivot, we have to give appropriate column names, because now we'll have two columns for the categories present in the employee feature. When we give the names and we run the code, here's the output that we get. So here's the data. We have the original melted data, and here is the data which has been rolled back. You have an index, you have employee A and employee B, exactly opposite of what we did in the previous one. So if you have an input like this, using melt, you can bring it to this format. If you have an input like this, using pivot, you can bring it to this form. Next, moving on to an important function called rabble, and we'll talk about it because this is used to flatten the input. Now, you may not realize that right now, but if you later on start working with images, especially in the area of computer vision, you'd realize that the images that we give as an input to a machine learning model are always flattened. They are made one-dimensional. So if you have any data, which is an array-like data, let's say a matrix, in this case, which is a two-dimensional matrix, and you want to flatten it, Rabble is the method that's used for it. So this is our array, which is going to be a two-dimensional array. 1, 2, 3 is first row, and 4, 5, 6 is second row. And to that, when we apply Rabble, we look at the flattened array. Let's see how it comes up. See the output? It says 1, 2, 3, 4, 5, 6. 1, 2, 3, row-wise, and 4, 5, 6. If you wanted to go column-wise, let's say you wanted to get the value 1 first, and then 4, then 2, and then 5, and then 3, and 6, you can mention an input here, which is called F. That's the code for it. You just run it, and here you go. So 1, 4, 2, 5, 3, 6. By default, it'll go as per the rows, 1, 2, 3, 4, 5, 6. But if you want to change the order, you can do it like this. Next, we have a method called reshape. And as the name goes, it's used for reshaping the arrays. So if you have a NumPy array, which is, let's say, a one-dimensional array, it is showing values like 1, 2, 3, 4, 5, 6. And you want to reshape it to 2 rows and 3 columns. Then you can do a dot reshape and just mention the number of rows followed by the number of columns and look at the output. Very commonly used in machine learning, because when we do a split of our data into X and Y variables, you often see this being used with the Y variable to kind of change its shape. So you had 1, 2, 3, 4, 5, 6, and you change it to 1, 2, 3, 4, 5, 6 like this. Also, you'd often see at one of the places here, either at row or column place, they'll just put a -1. So -1 essentially is just a special convention that indicates automatic calculation of the size along that dimension. What does it mean? So instead of writing 2, 3, if I write 2, -1, the input to this method is that we want 2 rows, whatever number of columns it takes. It doesn't have to be explicitly given. It'll automatically figure it out. As long as we are saying 2 rows, it'll figure out the number of columns. Why? Because we've given this as -1. -1 means whatever number of columns it takes, we'll figure out. If I would have given a -1 and 3 here, it would say, I need 3 columns, whatever be the number of rows it takes. So let's see what happens. It's again going to be the same because we had 6 elements. And if you have 2 rows, they can be conveniently placed in 2 rows and 3 columns. That's how it's figured out. Next is, again, an important method called where, which is available in NumPy. And this is used for a lot of treatments. It's pretty similar to the Excel's if-else condition. So you have a condition here. If that condition is satisfied, you go with option A, else you go with option B. Let's say we are going to increase the total bill by $5 if the bill is less than 20. Then what are we saying? We are saying wherever we encounter a total bill which is less than 20, we are going to take that value and add 5. Otherwise, we'll leave it as is. So this is the condition. This is option 1, which will be executed if condition is satisfied. If it is not satisfied, then we'll go with option 2. Let's see what happens when we run this. So we've overridden the actual original column. If you remember, the first value here used to be 16.99. Because that was less than 20, it has added a 5 to it. Else we could have stored a new column here instead of overriding the original column. The difference would have been a lot more clearly visible. Next is zip. Again, a very important method often used with loops, etc. Let's see how does it work. So let's say you have 2 features or multiple features in your data that you want to work with, but you want to form a combination of these. For example, you may have an employee with the same name, but at a different location, right? So you don't want to identify the employee with the location alone or with the name alone. You want to identify it as a combination of name and location. So let's say we are doing a zip as it goes, zipping the column day and time, and we are forming it in the list kind of a shape, and we are looking at the first few observations of that. Let's see what happens. See, so it has taken the day and taken the time, which was dinner or lunch, and it is showing me those combinations. Where do you think it can be useful? Let's say we want to perform an operation of sorting on data. We have 2 lists. One is categories, A, B, C, D, and other is a collection of some numbers, 3, 1, 4, 2. Now we want to do some kind of a sorting operation, but we also know that A is connected to 3, B is connected to 1, C is connected to 4, and D is connected to 2. They are not randomly placed. They are in some order because category and numbers are related. How can we do a sorting on this such that A, B, C, D is appropriately aligned to it? We can do an independent sorting of this, but we don't want to forget the connection between the categories and the numbers. How can we do that? We can do that with the help of zip, and then we can apply a function called sorted here, which will be able to do this for us. Let's see what are we doing. We are taking the categories, we are taking the numbers, we are doing a zip and putting it to a list, pretty similar to what we did here, right? Then we are saying apply a function called sorted to these combination pairs. And we are mentioning key is equal to lambda x colon x1. What does it mean? So this lambda function is a function on the go. It doesn't have a function body or a definition. It is on the go. What we are saying is that from the combined pairs, take the value at index 1. So this will be index 0. This will be index 1. We are taking the value at index 1 and we are sorting on that. Sorted function needs to know on what key, on what input it needs to do sorting. It can do an alphabetical sort also, right? But we want to sort on the numbers. So we are saying index 1, which is belonging to numbers, is where we want to apply sort. And then we can finally print the output for category and numbers in the sorted pairs, print the category and print the number. Let's see what we get as an outcome. So you get this B1, D2, A3. If you see, it's maintaining the understanding of category and number association. So this is about some of the important methods and attributes that anybody who practices data science needs to know all the time. Hope you had something meaningful to learn from this. Thank you.